It's August 1945, and 10 of Germany's most brilliant nuclear physicists are locked inside this sprawling English country estate called Farm Hall.
Right.
And they think they're simply prisoners of war, just waiting out the aftermath of a devastated Europe. But what they don't know is that British intelligence has bugged every single room.
Oh, yeah, every room.
MI6 is listening to their whispers, their arguments, their panic. And the most intense moment comes when they turn on the radio and hear that the United States has just dropped an atomic bomb on Hiroshima.
The reactions captured on those secret tapes are just historic. I mean, we hear shock, disbelief, and then a frantic scramble as the man who led the German nuclear program tries to reverse engineer the physics of the American bomb out loud.
In real time.
Yeah, in real time to his fellow captives.
Well, welcome to this deep dive. Our mission today is to unpack the mind, the science, and the, really profound controversies of that man, Werner Heisenberg. We're using excerpts from his comprehensive Wikipedia article as our sole source map to guide us today.
And it's quite a map.
Yeah, it is. Because for a lot of you listening, the name Heisenberg immediately brings up the image of Walter White's alter ego in Breaking Bad.
Right, the guy with the hat.
Exactly.
Yeah.
But the real Heisenberg's life is far more complex than a fictional cartel boss. We are looking at a historical and scientific landscape that is incredibly murky.
We really are. We're examining a man who redefined the limits of human knowledge regarding the fabric of reality itself, while simultaneously navigating one of the most oppressive regimes in human history.
Yeah.
The texts present us with this staggering puzzle. Like, how do we measure the legacy of someone who revolutionized our understanding of the universe, but whose political and moral choices remain a subject of fierce debate?
Right. So to understand the choices Heisenberg made later under the Third Reich, we first need to understand how his brain processed the world.
Exactly.
The sources show us a thinker who fundamentally rejected comfortable, established models. And the catalyst for his greatest scientific breakthrough wasn't, a state-of-the-art laboratory.
No, not at all.
It was a severe case of allergies.
Yeah, it's wild. In the summer of 1925, Heisenberg was suffering from a horrific bout of hay fever.
Just terrible.
Desperate for relief from his swollen face and constant sneezing, he retreated to Helgoland, which is this tiny, rocky, completely pollen-free island in the North Sea.
Okay.
He was alone, recovering, and just consumed by a crisis in atomic physics. Because the existing models of the atom were failing, the math simply wasn't matching the experimental data coming out of the labs.
The classical approach at the time, it relied heavily on visualization.
Yeah, physicists were trying to draw mechanical pictures of atomic structures they could never actually see.
And Heisenberg just decides to abandon that entirely. On that barren rock, he writes what becomes known as the Umditum paper, which translates to reinterpretation.
Right.
He adopts a strict doctrine that was pushed by his colleague, Wolfgang Pauli, which is to completely reject unobservable quantities.
What's fascinating here is that rather than guessing where an electron was at every moment in its orbit, Heisenberg focused solely on the observable data.
Just the hard numbers.
Exactly. Specifically, the frequencies and intensities of light emitted or absorbed by atoms when they transition from one energy state to another. He argued that physics must restrict itself to the relationships between these measurable transition states, ignoring whatever happens in the dark spaces between them.
Okay, let's unpack this for a second. Think of it like trying to understand a wildly complex tap dance routine.
Oh, I like this.
Imagine you're sitting in a theater, but there's a heavy curtain blocking your view of the stage. All you have is the rhythmic sound of the dancer's footsteps.
Right.
For years, physicists were sitting in the dark trying to construct these elaborate theories about what the dancer's arms were doing or what expression was on their face.
Guessing, basically.
Yeah, guessing. And Heisenberg finally stands up and says, "Stop guessing about the arms. Just write down the rhythm of the footsteps. That's the only real data we have."
And recording those footsteps required a radical shift in mathematics. Heisenberg realized that the numbers representing these atomic transitions didn't behave linearly. Well, when you multiply property A by property B in his new system, the result is not the same as multiplying B by A.
Wait, really?
Yeah, this non-commutative property was bizarre for physics at the time. Max Born, who was his mentor in Göttingen, reviewed Heisenberg's paper and recognized that Heisenberg had independently stumbled upon and applied matrix mathematics.
Wow.
Yeah, he was arranging the probabilities of these quantum jumps into grids rather than continuous equations. And he wasn't even super familiar with the mathematical theory of matrices when he did it.
That's insane. It fundamentally severed physics from human intuition. I mean, you can't draw a picture of a matrix probability grid the way you can draw a mechanical gear.
No, you really can't.
But this obsession with trusting only the measurable data leads directly to his reality-shattering discovery 2 years later in 1927.
Following the mathematical logic of those matrices where, again, A times B is distinct from B times C, A. Heisenberg hit a hard limit.
A wall.
Yeah, he proved mathematically that there are pairs of properties, specifically a particle's position and its momentum, that cannot both be measured precisely at the same time. The more precisely you pin down one, the less precisely you can know the other.
The uncertainty principle.
Exactly.
Though the sources point out he originally used the German word Ungenauigkeit, meaning imprecision.
Right.
So what does this all mean? For you listening right now, a helpful way to visualize this mechanism is to think about taking a photograph of a very fast-moving car at night.
That's a great way to look at it.
You have to make a choice with your camera settings. If you use a super fast shutter speed, you freeze the car perfectly in the frame. You know its exact location, its position is certain, but the picture is completely static, meaning you have zero information about how fast it was moving.
You lose the momentum,
Yeah.
and the alternative is using a slow shutter speed.
Right. With a slow shutter speed, you capture a long, beautiful streak of blurred light. You have a great measurement of its motion, its momentum. But where exactly is the car within that blur?
It's impossible to say.
Yeah, you cannot capture both the exact location and the exact speed simultaneously.
And what's crucial here is that this limitation isn't a glitch in our cameras or our microscopes. Heisenberg elevated this to a fundamental law of nature.
It's just how the universe works.
Exactly. And it led him to a philosophy of anti-realism. He argued that science no longer describes nature itself. It describes our interaction with nature.
Wow.
Yeah, by the very act of observing, setting up the experiment, we force the universe to take a state. Method and object are permanently entangled. The idea of a passive observer looking at an objective clockwork universe was just dead.
And that concept terrified a lot of physicists. I mean, Albert Einstein notoriously despised the idea that the universe lacked fundamental objective certainty.
He really did.
But the sources show Heisenberg was deeply comfortable dwelling in that blur. He was heavily influenced by Plato, and he noted that conversations with the Indian philosopher Rabindranath Tagore were crucial in helping him make sense of quantum paradoxes.
Yeah, Tagore introduced him to concepts within Eastern philosophy, such as those found in Advaita Vedanta,
Okay.
which had long embraced the idea that the observer and the observed are not distinct entities, but interconnected parts of a whole. In those traditions, strict objective reality is often viewed as an illusion. Finding philosophical frameworks that accepted paradox allowed Heisenberg to accept the mathematical reality of quantum mechanics.
Heisenberg has just proven mathematically that absolute certainty is impossible. But outside his window in the 1930s, a political movement is rising that violently demands absolute, unquestioning certainty.
Yeah, a massive shift.
The clash between his quantum ideology and the rise of the Nazi regime creates an immediate, dangerous crisis.
It did. The regime championed a movement called Deutsche Physik, or Aryan physics. Prominent figures in this movement, including Nobel laureates like Philip Lenard and Johannes Stark, despised theoretical physics.
They hated it.
Yeah, they viewed theories like relativity and quantum mechanics as abstract, Jewish inventions that corrupted the purely visual, classical, and supposedly German way of doing science.
It goes right back to the tap dancer.
Yes.
The Aryan physics movement demanded to see the arms and the legs of the dancer, while Heisenberg was dealing in unseen matrices and probabilities. And because Heisenberg fiercely defended the theories of Albert Einstein and taught quantum mechanics, he became a target of the state.
In 1937, the official SS newspaper, Das Schwarze Korps, launched a vicious campaign against him.
Which is terrifying.
Absolutely. They labeled him a white Jew, which was a derogatory term for an Aryan who supposedly acted and thought like a Jew. The article openly suggested he should be made to disappear. In a totalitarian state, being named an enemy of the SS was a very real death threat.
Here's where it gets really interesting. How does the architect of quantum mechanics navigate this life or death situation?
Right.
He doesn't use math. He uses his mother.
Yeah, this is incredible.
The texts detail one of the most surreal footnotes in scientific history. Heisenberg's mother happened to be acquainted with the mother of Heinrich Himmler, the head of the SS.
Out of all the people.
Right. Their families were connected through a Bavarian hiking club.
It sounds like fiction, but Heisenberg's mother visited Himmler's mother, essentially asking her to rein in her son. And the intervention actually worked.
Unbelievable.
Himmler personally reviewed the case and wrote to the SS, ordering an end to the attacks. He also wrote to Heisenberg, clearing his name, but included a chilling caveat. Heisenberg was warned to strictly separate his professional research from his personal and political attitudes.
And the historical texts we are examining point to a profound question here. Why did he stay?
Yeah, that's the big one.
He was an international superstar in physics. During a trip to the U.S. in 1939, American colleagues begged him to accept university positions and emigrate. Why remain in a totalitarian state that had just threatened to erase him?
Well, the sources outline his motivations neutrally, focusing on his ideological convictions. Heisenberg refused offers to emigrate because he supported the concept of Germany's renewal,
Okay.
held strong German imperialist convictions, and viewed German domination of Europe as a historical necessity. Primarily, he saw it as a bulwark against Soviet communism and what he perceived as the chaotic weaknesses of Western liberal democracy.
Right.
He felt it was his patriotic duty to remain and preserve German science for the post-war era, even though he did not join the Nazi Party. We have to look at these politically charged historical facts objectively, just based on what the texts say.
Exactly. We're just conveying the sources here. But it's almost like a macro-level uncertainty principle governing his own life.
Oh, interesting. How so?
Well, the sources suggest he was so intensely focused on measuring the momentum of German history and culture, preserving the scientific institutions, acting as a bulwark against the Soviets, that he completely blurred out the position. The horrific, concrete reality of the atrocities happening right in front of him.
That choice to remain brings us to the most debated chapter of his life. Because he stayed, the regime eventually drafted him to help build their most devastating weapon. He became a principal scientist in the Uranverein, the German nuclear weapons program, often referred to as the Uranium Club.
In June 1942, Heisenberg is summoned to report to Albert Speer, the Minister of Armaments for the Third Reich. The Nazi war machine needs to know if an atomic bomb is viable.
And Heisenberg informs Speer that a bomb cannot be built anytime soon. He outlines the massive resource requirements, stating it couldn't possibly be ready before 1945.
So what happens?
Based on this assessment, the military scales back the bomb project and redirects the focus toward building a nuclear reactor for energy production instead.
Which brings us back to the farm hall tapes we talked about at the beginning. This raises an important question for you listening to Wei. Was he a secret saboteur of the Nazi bomb, or just a scientist who failed at the math and rationalized it later?
When the news of Hiroshima breaks over the radio at Farm Hall, the secret transcripts revealed the German scientists were utterly stunned. Heisenberg himself initially refused to believe it, thinking it was an American propaganda bluff.
Wow.
Yeah. In the recordings, he frames their own failure as a moral choice, saying, "We wouldn't have had the moral courage to recommend to the government in the spring of 1942 that they should employ 120,000 men just for building the thing up."
But the deeper analysis of those transcripts, particularly the work of physicist Manfred Popp mentioned in the article, dissects the actual mechanisms of Heisenberg's scientific failure.
Popp's work is crucial here.
Yeah. Popp analyzed the farm hall tapes alongside captured documents and found that when Heisenberg tried to explain to his fellow captive scientists how the American bomb might have worked, he made fundamental calculation errors.
The primary error was a misunderstanding of critical mass.
Okay, break that down.
Heisenberg hadn't properly distinguished between the physics of a nuclear reactor, which uses slow, moderated neutrons, and the physics of a bomb, which requires incredibly fast, unmoderated neutrons in pure uranium-235.
Got it.
Because he hadn't fully worked through the fast neutron chain reaction mathematics, his back-of-the-envelope estimates for how much uranium was needed for a bomb were drastically off, sometimes by literal tons.
The sources show he admitted on tape that he had never actually calculated the critical mass of an atomic bomb prior to that moment at Farm Hall.
Which is astounding.
Prominent physicists on the Allied side, like Edward Teller and Hans Bethe, reviewed the transcripts and concluded the same thing. Heisenberg was trying to figure out the bomb's mechanism in real time, under pressure, and getting it wrong.
Popp's historical analysis concludes that Heisenberg didn't actively sabotage a bomb program because he actively avoided focusing on the bomb at all. He concentrated his efforts on a reactor. While there may have been a subconscious desire not to hand a weapon of mass destruction to the regime, The glaring lack of mathematical foundation severely undermines the post-war narrative that he fully understood the bomb and deliberately hid the knowledge.
The sources also document troubling statements he made after the war, which complicate his legacy even further.
Yeah, I do.
The brilliant physicist Lise Meitner, who had to flee Germany because she was Jewish, later confronted him about the horrors of the Holocaust. According to her accounts, Heisenberg responded by saying, "Unfortunately, every spiritual upheaval has always been accompanied by great cruelty."
The Wikipedia article also cites an account from Rudolf Peierls, a British-German physicist, who recalled a conversation with Heisenberg in 1947. Peierls noted Heisenberg stating that if the Nazis had been given another 50 years in power, they would have become quite decent.
We are reading texts that portray a man capable of grasping the invisible matrices of quantum mechanics, yet seemingly compelled to rationalize the devastation caused by the regime he lived under through a lens of historical necessity.
It's hard to reconcile.
It forces you to recognize that unparalleled scientific brilliance and moral clarity are completely separate variables.
The sources present a historical figure who defies simple categorization. Heisenberg rebuilt German science after the war, served as a key figure in international scientific cooperation, and won a Nobel Prize.
Yeah.
Yet, his compromises, his nationalist pride, and his rationalizations remain permanently etched into his biography.
As we wrap up this deep dive, I want you to think about the inherent blurriness of human legacy. When you try to measure Heisenberg's life, the closer you look at his scientific genius, the more ambiguous his political and moral positions appear.
Just like his own principle.
Exactly. The uncertainty principle he discovered in the microscopic world seems to govern how we view him in the macro world.
And there is one final fascinating paradox from the text we reviewed. Heisenberg was the primary architect of quantum uncertainty. He proved that the universe, at its fundamental core, is probabilistic and unknowable to us. Yet, throughout his life, he was a devout Christian who believed physics was a way of uncovering the structure of divine creation.
The tension there is incredible. The physicist who proved the universe is fundamentally blurry still believed in a higher power.
We see this clearly in his final correspondence with Albert Einstein. Einstein famously rejected quantum randomness, insisting that God does not play dice.
Right, classic Einstein.
Yeah. But in his last letter to Einstein, defending the validity of quantum mechanics, Heisenberg wrote, "We can console ourselves that the good Lord God would know the position of the particles. Thus, he would let the causality principle continue to have validity."
I want you to mull over that profound contradiction.
It's a lot to think about.
The man who proved that the universe is fundamentally unknowable to human observation, who lived his own life in the deeply murky, blurry gray areas of history, ultimately relied on a God who could still see the absolute truth. A God who didn't need a slow shutter speed, who could look at the chaotic universe and see the perfect, unblurred photograph.